4 kilometers will be what? Will be 4 multiplied by 100,000 cm. So by so doing, we have succeeded in converting these two values to the same units, cm and a cm. That means we have 1 cm to 400,000 cm. So the next thing is to write them in the representative fraction scale. Note that the numerator is the mark distance, while the denominator is the ground distance. So to write it in RF scale is what we have: 1:400,000 cm. The next thing you do is to divide until the numerator becomes 1. But obviously, as you can see, there is no need to divide because the numerator here is already 1. Therefore, the new scale in RF form is 1:400,000. So that is how to convert from the statement scale to the representative fraction scale. Now, it's also possible to convert from a representative fraction scale to a statement scale. And the procedure are as follows. The first thing you do is to write out the representative fraction in the same unit, just like we did previously. Then you divide the ground distance in cm by 100,000. Now let's take this example. Convert 1:50,000, 1:50,000 to a statement scale. To convert this to a statement scale, the first thing you do is write it out in representative fraction, which is what we have done. And this is the same thing as 1 cm is to 50,000. Having established that, we say that 1 cm represents 50,000 divided by 100,000. And if you do this simple division, you have that 1 cm to be 1 cm represents half kilometer, or if you like, 1 cm to half kilometer. It is also possible to convert from linear scale to statement or representative fraction scales. In this case, you use a ruler to measure the length of only 1 unit on the linear scale, from 0 to the next unit on the right. Then you measure on the ruler. The measurement you derive on the ruler will now be related to the linear scale in the distance on the map. What am I trying to say? I'm saying that after using the ruler to measure, that measurement on the ruler in relation to the linear scale will now become the distance on the map. For example, if we are given this question to convert the linear scale below to a statement scale and representative fraction. You can see from the diagram there that we have half, 1/4, 0, 1, 2, up to 3 kilometers. And now, to solve this problem, assuming the distance from 0 to 1 on the map scale using ruler is 1 cm. Let's say we have measured the distance between 0 to 1 on the map using the ruler, and we have 1 cm. And then the distance on the ground is 1 kilometer from the scale. So it therefore means that the statement scale is 1 centimeter represents 1 kilometer. And for the representative fraction scale, it means that 1 centimeter will be equal to 100,000. That is 1:100,000. Okay, now let's look at the size of scales. Scales could be small, could be large, but we must be careful so that we don't get confused by the values. Now, for a small scale map, such a scale shows large area with little detail. You see a map covering a very large area but showing little or no detail is referred to as a small scale map. In this case, we say that the larger the denominator, the smaller the scale of the map. For instance, if we have a map with a scale of 1:1 million, that's a small scale map. Don't forget, we said the larger the denominator, the smaller the scale of the map. Someone may easily get confused and said, a map with a scale of 1:1 million, that should be a large scale map. No, that is not how it is done. The larger the denominator, the smaller the scale of the map. This is because such a map covers a wide area but has little details. So now let's look at a large scale map. A large scale map shows small area with more details. And also, the smaller the denominator would be, the larger the scale of that map. For example, we have a map with a scale of 1:20. That is indeed a large scale map. So, we can say that the smaller the scale, the larger the map, and vice versa. So, if we have a small scale, it therefore means that we have a large map. If we have a large scale, we have a small map. Now, there is a little test here to test your understanding or to assess your understanding. Now, the question is, arrange the following scales in ascending order. We have 1:50,000. The next one is 1:200,000. The next is 1:200. The next one we have 1:3 million. And finally we have 1:500,000. So in order to arrange these scales in ascending order, first of all, you must understand what the term ascending order means. Ascending order means that you have to arrange these various scales according to, or from the lowest or from the smallest to the highest, or if you like, to the biggest. So from the various scales that are given, which would be the smallest scale? Obviously, the smallest scale there is 1:3 million. Why is it 1:3 million? Remember we said that the larger the denominator, the smaller the scale of the map. So obviously, from the scales given, 3 million, 1:3 million is the largest denominator. So automatically that has made that scale the smallest scale. So to arrange in ascending order, we have 3 million, 1:3 million at the bottom, followed by 1:500,000. Next is 1:200,000. Then we have 1:50,000. Finally, we have a scale of 1:200 as the largest scale. So don't get confused when you see map scales in determining which is smaller or which is larger. Alright, so now let's consider measurements of map distances. How do we make measurements on the map? Now, map distance is the interval between 2 points on the map. 2 points may be straight or curved. The interval between 1 point or one location on the map and the other at times may be straight, at times it may be curved. But whatever is the case, it does not stop our measurements. If it is straight, we measure it with a ruler. If it is curved, we use our thread to trace along the curve or the curved nature of